So for our second part, we're going to factor 4 terms. So number 1, we're first going to group them in 2 groups. So most of the time, how they're arranged will work. So we'll just look at the first 2 numbers, pull out a GCF, and then look at the second 2 terms, pull out a GCF. And the whole hope is, once we've pulled out the GCFs from each of those chunks, it looks something like this, where the remaining stuff matches, and we'll factor that. So factoring 4 terms, you're actually factoring 3 times. The GCF out of the first 2 terms, the GCF out of the second 2 terms, and then at the end, a GCF, okay? If for some reason it's not arranged the way you want, plus and minuses, we can move around as long as we keep the signs where they are. So you can kind of rearrange them. And that's ultimately what we're going to do. But the number 1 thing, and I always forget it, so don't pull a Molly, but the number 1 thing is always look for a GCF of all of them first, okay? And initially we won't have it, but down here we will, and not like down here, guys. See how we can pull out a 2 from the very beginning? I always forget it, so don't let me forget that. All right, so number 1, do we have a GCF we can pull from all 3? No, okay? The first 2 have a 3, the other ones just have variables, none of them have all the same variables, so what we're going to do is we're just going to focus on these 2 terms. Basically, if you could, you'd put white out on the rest of it, okay? So looking at negative 3v and negative 3x, what can we pull out? A negative 3, and she even said the negative, and that's how my math lab is. They want you to pull out that negative if you can. Can you pull out a variable, though? No. So what we're going to do is we're going to factor out a negative 3, and then we're going to say what remains. Well, a negative 3 divided by a negative 3 is just a positive 1, so we don't need to worry about a number, but what variable is still there because we didn't touch him? The v. And then the second term, what's a negative 3 divided by a negative 3? A positive 1, so we're going to make note of that sign change. Do I need to put the 1 there? No, because what's a good placeholder? The variable that's there is x. Guys, if you put 1v or 1x, I do not count off. I'm okay with coefficients of 1. My math lab might not be, though. So they might give you a red x, and it might just be because you have 1 as a coefficient, not because you did the problem wrong. All right, so what's our whole goal? Our goal is when we go to the second 2 things, that after we pull the GCF, the remaining thing is v plus x. Okay, so that's like what we're shooting for. We want a v plus x left. So when you look at these 2 terms, again, if you could kind of just white out that, what do they have in common? A u, and I'm going to say a positive u. I want to stress that you're always putting a sign, positive or negative. So we're going to pull out a positive u. When you pull a u from uv, what are you left with? V. When you pull a u from xu, what are you left with? A positive x. And what have we done? We've taken this 4-term thing and changed it to exactly what we were doing up here. Right? Do you guys see that? So now, the first term, as ugly as it is, and the second term, as ugly as it is, they have a GCF that we can factor out. So let's factor out this v plus x and pull him all the way to the beginning. When I factor him out of the first term, what's the only thing that's left? Negative 3. And when I factor him and pull him out of this term, what's the only thing that's left? Why did I put a parenthesis there? I don't know. A plus u. Does that look right? This is not the right lingo, but we just unfoiled. Right? Do you guys do FOIL in 112 or the previous, like, when you distribute first, outer, inner, last, or whatever? We just unfoiled. So how do you check that we factored correctly? You would FOIL, right? You take v times negative 3, you would get negative 3v. v times u, you would get vu or uv. Hey, that was one of our terms. You take x times negative 3, you get a negative 3x, and you take x times u, get xu. So you can always double check your factoring by redistributing. All right, looking at these 2 terms, actually looking at all 4, there's nothing we can pull out of all 4, so I'm just going to look at the first 2. They share something in common. What can I factor out? A u. What will that leave in the binomial? Y plus 7. Does everybody see that? The y remains from the first, and the 7 remains from the second. Looking at the last 2 terms, shoot for the small things, we want y plus 7 left. So what can we factor out that will leave us with the y plus 7? A w, and not only a w, but a positive w, because the second you don't put a sign there, you're kind of guessing when you go to this next step, okay? So when we pull out that w, what are we left with? Y plus 7. Yay! Celebrate the small things. That's what we want. So y plus 7 matches. So that's who I'm going to pull out one last time. When I factor them out of the first term, I'm left with a U, and then this is what I'm talking about. If I don't put a plus there, you're kind of always guessing, is it a positive, is it a negative? So put that plus, put that negative, so we know that it's a positive W. Is that good? All right. The next one. Is there anything out of all four that I can pull out? Is there a GCF for all four? No. Can I factor anything out of 3xy and 2 as they are? No. So what does this mean? It means we can rearrange. So we can do step number 4. We can arrange them. Who do you want to pair with who? The 3 and the 3. So I'm going to do that first, and then before I'm too quick to write the second part, I want to kind of make you start thinking about stuff. So I'm going to leave 3xy alone. He's going to be my front, 3xy. And when I move the 3x, the sign that's in front has to go with them. So that will be a minus 3x there, okay? Don't be too quick to write the remaining stuff. All right. So remember what our goal is. We eventually want to factor out something so whatever remains matches the second half. So we have a 2 and a 2y left. But there is a certain order that we want it to do. So when you look at this term, where is the y located? In the front or in the back? In the front, right? You see the y's right here in the front? So when I write 2 and 2y, I want the y to be in the front. I want it to match. Does that make sense? So kind of try to write. If you don't do that, are you wrong? No, but sometimes it's weird to factor out stuff and to see that they match. So when I go to rearrange, I'm like, okay, I'm going to pull out a 3x, which is going to leave me this y in the front. So when I pull out this 2, I want the y in the front. So when I rewrite that, you're like, Molly, I'm not a math teacher. I wouldn't have seen that. I would have written plus 2 minus 2y. That's fine, but you would have just noticed your remaining guy was off by a sign, which gets a little difficult. So if you can do it earlier, it's better. All right, looking at these first two terms, what can we factor out? Say it louder, 3x, yep. When I factor out the 3x from the first term, that just leaves me with a y. I'm not changing signs because I'm just factoring out a positive. And then how do we show that the 3x was there? A 1. Back here, we know a 2 is shared, right? We know it's a 2. But notice what we want our sign to be. We want our y to be positive and our 1 to be negative. And what do you notice right now? They're the opposites, right? Our y is negative and our 2 is positive. So what can we do to switch signs? We factor out not just a 2, but a negative 2, okay? And that's always going to be the rule. If you see that the signs are flipped, factor out a negative, and it will correct that, okay? So let's factor out a negative 2. So a negative divided by a negative will give us that positive y, but the positive 2 divided by the negative 2 will give us that negative 1. Say you don't see it, and you just factor out a 2, and you're left with a negative y and a positive 1, don't force them to match. That doesn't match. So think, oh, I have it, but my signs are wrong. I need to factor out a negative 2. So if these don't match, don't just make unicorn dust happen, right? Don't make magic happen. There's a reason why they don't match. Go double check your sign, go double check your number, whatever it may be. All right, so they both share y minus 1. So did you guys get y minus 1 and then 3x minus 2? Does that look right? And again, if you're not too sure, FOIL that stuff, and you'll see that all 4 terms will reemerge. All right, number 4 is, like I said, where we are going to have a GCF. So looking at those 4 terms, let's put cell phones away. Looking at those 4 terms, what number and what variable can we factor out of all of them? A 2. Is there a variable that all 3 of them or 4 of them have? No, so it's just a 2. So when we factor out the 2, it's from everybody. It's not this factor by grouping, okay? So we're going to have one big giant thing of parentheses. So all the numbers just get halved, right? Just dashed by 2. So this will be 2ax minus 2ab minus bx plus b squared. Does that look all right? All I did was just divide each of my numbers by 2. So the 4 reduced to a 2, and then the things that had a 2, if you want to put a 1 there, you can. Otherwise, just put the variables there. All right, who is still part of our answer? The 2. So right now, if I'm doing my math lab homework, I'm typing a 2 right now because I'm going to forget about them. So 2 is part of my answer. It's the very first thing I'm doing. Do we want to have to write 2 for every single step? No, so what I do is I just do this arrow, and I write him down here, and I'm like, okay, he's part of my final answer, but he does not need to be part of my factor by grouping stuff. He'll just confuse me. So let's get him down there, and then keep going like we're doing. So now we're going to kind of ignore him, and we're just going to look at these 4 terms and do what we were doing, okay? So looking at the first 2 terms, what can you factor out of 2ax and 2ab? 2a. When you pull out 2a from 2ax, that leaves you with the x. When you pull out 2a from the 2ab, that just leaves you with a minus b. Does that look okay so far? And then back here, kind of the same idea. Notice the x is in front, the b is in back. That's exactly what we have going on. But notice we have a positive first term and a negative second term, and these are opposites. So what do we want to factor out? A negative, and then what do they both share? B. And that will take care of what we need, all right? A negative divided by a negative is going to be that positive x. A positive divided by a negative will be a negative. You had two b's, you took one away. All right, so now when we notice, you guys notice that x minus b does match? We're ready to kind of say our final answer. So when I factor him out, I'm going to put him right behind that 2. Is that okay? Because remember, the 2 is part of our answer. So I'm going to factor out the x minus b, but I'm going to put him right here behind this 2. And then when I factor him out of this first term, I'm left with a 2a. And when I factor him out of this next term, I'm left with a negative b. How do you check something like that? It's just kind of reverse order. The very first thing you did was factor out the 2. It will be the very last thing you do to distribute. So the first thing you would do is FOIL your 2 binomials, and then at the end distribute the 2, and you'll get back there. All right, 2 more, guys. You're doing great. Looking at these 4 terms, is there a number we can pull out of all 4? No, but what about a variable? Yeah, we'll pull out an x, okay? So we'll pull out the x, and again, it's a GCF out of all of them, so it's not a little grouping. I'm pulling it out of all of them. So we'll just mix all the x's, right? So this will become yw minus 5w minus 6y plus 30. Does that look right? Right now in my MathLab, I'm typing an x so I don't forget it. On my worksheet or on my test, I'm bringing him down so I don't forget him. And then looking at how it's arranged, it looks like they're okay. Like I'm not going to have to rearrange them. So looking at these first 2 terms, what can you factor out? A w. And what are you left with? Y minus 5. Perfect. All right. So remember, our ultimate goal is to have a y minus 5 left on the second part. So what do I need to factor out of the second part? Not just a 6, but a negative 6, right? We want to flip those signs because here the y is positive, and right now he's floating around with a negative. So we'll factor out a negative 6. So negative 6 divided by a negative 6 will give us a positive y, but then a positive 30 divided by a negative 6 will give us that negative 5 that we needed. All right, I'm ready to write my final answer. So when I factor out that y minus 5, I'm going to pop him behind this x that we already factored out. So we'll do y minus 5 down here behind them, and then what do we have? W minus 6, does that look right? And again, if you wanted to double check it, FOIL it first, and then distribute the x at the very end. So like, you put on your socks and then your shoes, but you got to take your shoes off before you take your sock off. So whatever's done first up here is usually the last thing when you're checking. All right, last one. It's actually okay as it is. Some people might not like it, and they might want to get the 4s together, but if you get the 4s together, the 16 and the y don't have anything. So it's actually okay as it is. So let's go ahead and dive into the first 2 terms. Notice none of them have something that we can pull out of all 4, so we're just going to go straight to the factor by grouping. What did those 2 have in common? A v and what else? A 4. So let's factor out a 4v. When I take the 4 and the v from the first term, it leaves me with a y. And when I take the 4v out of the second term, what is that going to be? A negative 4? Does that look right? Okay. So this is kind of interesting, and there's a reason why I put it on here. Notice what's left. The y and the 4 is what we want, right? We want a y and a 4, but what do you notice about the signs? They're opposite. So remember how I said, well, if you want to switch your signs, you need to factor out a negative. You're like, a negative what, though? Like, there's no number. And so what we're technically, and it seems so wrong, but I want to do it because if you don't, it looks weird. Just go ahead and factor out a negative 1. I know it looks weird, but the negative 1 is a number that they share, technically. And when you factor out that negative 1, it's going to switch your signs. A negative divided by a negative will be a positive. I didn't touch the y, so he's still there. And then a positive 4 divided by a negative 1 will switch the 4 to a negative 4. And why I like that 1 is because up here, I mean, we could have put a 1, but up here we had to know that when we pulled him out, there's a placeholder of 1. But when you factor out a negative 1, or excuse me, when you factor out the y minus 4, the negative 1's kind of already there, so you don't have to think of the place value. If you don't do that, that's fine. If you just want to put a negative there and switch your signs, absolutely fine. So we'll have y minus 4 factor out in front, and then we'll have 4b minus 1 for our remainder.